Now hello there, this is the second video in series of 7 about rates of reaction, and I'll have a look with you the effect of concentration of solutions and pressure of gases on the rate of a chemical reaction. So just to show you where we're going in the series, we're going to continue with surface area of solids, temperature catalysts, how to monitor a rate of reaction, and then finally end up with rates and graphs. So I'll start off defining what concentration means, and then we'll have a look at why increasing the concentration of a solution, or indeed the pressure of a gas, increases the rate of a chemical reaction. So concentration usually applies to solutions. And remember, a solution is a mixture of a solute, that's something that dissolves, and a solvent, that's a liquid that something dissolves in. So concentration tells us how much of a solute, that could be either mass in grams or moles, is dissolved in a given volume of solvent. So a solution with a higher concentration has got more solute in a given volume than a solution with a low concentration. Okay, let's have a look at an example. So we could have a reaction of a metal like magnesium here, and you can see a coil of it in the bottom of the conical flask, with hydrochloric acid. Now you've got a certain volume of hydrochloric acid, and the little black dots there represent hydrochloric acid particles. The rest of it, of course, will be water. Now this solution here has got a lower concentration than this one here, because in this solution we've got more particles in exactly the same volume of hydrochloric acid. In fact, in this example we've got exactly double the particles in the same volume of hydrochloric acid. And in chemistry, a solution with a higher concentration will always react more quickly than a solution with a lower concentration. In fact, doubling the concentration of a solution often doubles the rate of a chemical reaction. So if we increase the concentration, we've got more particles, and therefore we've got more collisions. Now, if you're answering a question about this in your exam, you need to say the following. So you've got more particles per unit volume, and therefore more collisions per unit time. Now, in the example we've just had, we doubled the number of particles per unit volume. So you could say the rate of reaction doubles because there are double the number of particles per unit volume, and therefore double the number of collisions per unit time. Now, the concentration of a solution and the pressure of gases are closely related. The more particles you've got per unit volume of a gas, the higher the pressure. Now in this example here in our 3D container, we've got two different gases that if the particles collide could react together. And this would have a lower pressure than this example here, where we've got exactly double the number of particles of each gas. Now exactly the same thing happens to the rate of reaction. Increasing the pressure means we've got more particles and therefore more collisions. More specifically, a higher pressure we've got more particles per unit volume and therefore more collisions per unit time. So just to sum up, increasing the concentration of a solution or increasing the pressure of a gas will always increase the rate of a chemical reaction. And it's because there are more particles per unit volume and therefore more collisions per unit time. Note carefully that increasing the concentration of the pressure does not change the energy of the particles at all. Okay, so that's rates of reaction, concentration and pressure, hopefully made simple. Thanks for watching.